Welcome everyone. We're in Let's Talk AI and we're with Pablo Sánchez Naharro. And we're going to talk a bit today about different things. But can you introduce yourself, Pablo, and who you are in a few sentences?
Hi. Well, thank you very much for having today with in the book in the podcast with you. I am a telecommunication engineer, and then I specialize myself in data science and advanced analytics. Then I had some experience in time series analysis, especially in the business area. I'm really passionate about solving problems in a practical way, not just in the theory. And currently, I am in my third year of the PhD, and I am presenting in half year from now.
Great, thanks. Thanks for this introduction. So I would have a question for you,
Mhm.
just to maybe introduce the matter of artificial intelligence. Um, what have been your first contact with AI?
The first contact with AI was in the Biotechnological National Center. It was in the summer in an internship, and they proposed me to apply super resolution to biological microscopy. Basically, the idea is to increase the resolution of a picture, and this is what Photoshop has in some of the filters and can be done in a in our computers. But the important thing there is that it was a neural network, the one increasing the resolution, and it was my first attempt to deal with the artificial intelligence. Uh, well, I like to say that we have a really good neural network, but we had no output at all. But it was my first step in the research world, which it's important, especially for my PhD now. And also, I learned a lot how to deal i- i- with the lack of information, which I think it's a really big barrier in this field, in the artificial intelligence and in general in data analytics. And this is why I was really excited when you proposed me to come here to the podcast, because I think this really makes a difference. This breaks a barrier and can help a lot of people.
Well, I'm very happy to hear that, and yeah, this is one of the big ideas of the podcast is to break down some PhD work or business cases or how it is in reality, and talk with experts like you that dedicates years of their life towards a few specific parts of the AI big entity. All right, thanks. So what was the first time you contacted with the company's word, and how did you use time series on your first job?
The first time I applied artificial intelligence was in my master thesis. I was working with Devo. Devo is a company that receives real-time data,
Okay.
processes and create value by creating dashboards for managing companies or for managing some process in the companies. And then having all that data for being processed is a really good opportunity to apply artificial intelligence, and
Mhm.
especially in time series analysis. This was a sequence of events, and for making some prediction of the events. Where I remember we developed a framework for the app that they have that automatically creates and trains neuronal networks based on the events that they are happening in the sequence of events. But it was a bit different. Up to that moment, it was used LTSMs, but we decided to attack the problem in a different way. It was based in the Attention is All You Need paper that the Google guys had at that time. And also, it's really important how you show the information to the final user. It's
Mm.
not only getting the prediction. Our output for the prediction was the probability of happening of a given event,
Yes.
but pro- how you show the information. In our case, we have in the y-axis all the possible events, and in the x-axis it was time. So we assign a probability with circles. area of the circle assigned was describing the probability, and then we keep track of the probability and the event that really happened. Why?
Okay.
Because in time series we have uh, two dimensions for the error. We have the event error. You can make a mistake on the event that it's going to happen, but also
Yes.
you can make a mistake in the time. If you
Yes.
are predicting one event, but then one random event just go in the middle, it doesn't mean that you failed. You didn't fail. Your prediction was correct. You just went one sample in the time. So this
Okay.
is really important to focus on those two dimensionality because it really affects it in a different way.
Okay.
In that in that case, we were using TensorFlow. We tried to use Keras, but there were a limitation at that moment
Okay.
because there were a model training. I at the same time it was making prediction, and with Keras you had to train, you have to save it, and then you have to load it for using it. But this way, you have the same model. It was connected. So
Okay.
TensorFlow, which is the base of Keras, allowed to do that.
Okay, okay. Just before you said that this proposal was an alternative to the classical neural networks
Mhm.
used for LTSM. Can you remind what was LTSM?
Yeah, these are the long-term memory cells that basically are feedback. They are neuronal cells with the output with feedback output, so that uh, you keep giving the events and it has the memory that the event that have gone through that. In the case
Yes.
of attention, you just give the sequence of events that have happened. They have no memory, but
Mhm.
they are more powerful.
Okay, great, thanks. And okay, so you said that at this period, Keras was limited because you needed to save first the models that have been developed before being able to using it. So you used TensorFlow, correct?
Yeah, that's correct.
Okay, okay, and so you said that the two dimensions that were needed to take into account was first of all, well, the probability of the models that have been trained, and second, the input of time that comes in,
Mhm.
because if an unexpected input comes and creates a prediction, then it unbalances things, correct? Or you
Yeah,
need to redefine?
yeah, that's correct, and I think that this is the most difficult part of time series.
Hmm.
Get an accurate prediction. Typically, you want a prediction, sometimes of an event, sometimes of a value, but you want to be accurate in time, because
Hmm.
otherwise, well, if you are making a prediction about when a piece is going to break,
Yes.
uh, then you need to give be somehow accurate in when it's going to break. Otherwise, it has no value at all. We
Yes.
all know that something is going to break at some point. So this is really important.
Okay, cool. Thanks. All right. And so maybe you can share a little bit of the challenges that you faced and how did you solve them working on this?
um, yeah, during my years working, I think the biggest challenge that I faced have been taking
So
advantage. Yep.
just one question: Are we going are you going to share more challenges regarding your overall career or on this time series, for example?
I think this is well, this is for the time series, but this has across all the career. So
Okay, because
yep.
so after you worked with Devo, if I'm correct, so
Mhm.
you've been working at Airbus, and now you're doing your PhD, correct?
Yeah, first I was with Devo, then I went to Airbus, and now I'm doing the PhD that we are making some collaboration with the University of Oxford.
Awesome. Okay, great. Okay, can you share the
Mhm.
challenges that you
Yeah,
faced?
yeah. I think that the biggest challenge was the multiprocessing capability in Python. Originally, Python was designed for be single processor, and then all this artificial intelligence and data science and multiprocessing uh, will appear. And I remember wasting a lot of time the first time I used the multiprocessing package in Python because even it was multiprocessing, the things occur in parallel, but not literally in time. What it was multiplexing the different threads of the system, but the reality is that you didn't save time because you were blocking one task to execute the other one. So yeah, then I managed to do so. They allow to use different processors, but and nowadays we are using Dask. But I think this is a really powerful library because it allows you to swap from programming and debugging to launching the process in a real cluster just by swapping one or two lines of code. I think this is really powerful. You just create a cluster, you create
Mm.
a Dask cluster, you only
Mhm.
interact with the Dask cluster, but internally how the how you have the workers and the masters of Dash. This is absolutely transparent for you, so you can connect it to Amazon, you can connect it to Azure, Google Cloud, Kubernetes, and even if you want to make some local test, you can turn on another machine. You just give the IP address, and it create a cluster between that machine and your machine. And I think this is really powerful just by swapping two lines of code. And
Mm.
this changes completely the paradigm and removes a lot of barriers. When you, for example, when you were using multiprocessing in Python, and then you want to go to production, you need to make a lot of changes because the infrastructure in when you are developing is absolutely not the same when you are in production, and this helps a lot and saves time to the production team.
Awesome. Thanks a lot for this tool and the visibility on how to do multiprocessing with Python. As we understood that it's complicated, but with this tool we are able to manage and to do it well on production. As the production setup is not always the same as the one we're testing with.
Mhm. Yeah, I think
Uh,
it saves a lot of time. You may need a final step if you are going to a big product in a big company because that if the artificial intelligence is your product, but it's not until the last step when you need to do changes. Then you have the same tool all over the pipeline of production.
All right, perfect. And so you said before that you worked at Airbus. So what was your job at Airbus, and in what did it consist?
I was working in the part in ATA 49 department, which is the APU, the auxiliary power unit. This is a specific part in the tail cone of the plane, and my work was basically developing algorithm to detect whether a component is degrading, and therefore you need to act for maintenance the piece or just replace it. And the idea is to prevent failures. Even the plane has a lot of redundancy and absolutely it's a really safe place. Uh, when you need to apply maintenance, you may not be in the place where the mechanic are. So you want to organize your routes so that, or at least detect that this piece may become faulty so that you can act. And the idea is that aircraft is not on ground so that the company is not wasting money. And this is the value that we are adding by applying analytics. Um, Again, we were using temporal series and well, with the complexity of time, the two dimensionalities that we were talking before.
Hmm. All right, great, thanks. And could you share, maybe it's confidential, but could you share the tools that you used while working at Airbus? Maybe it's the main one,
Yeah, well, some of the tools are confidential, so I cannot share them. But
of course.
for creating the algorithms, we were using Python. We were using PySpark as well because of the tons of data that we were dealing with, and also
Yes.
Jupyter for interacting with Python in an easy way, and then creating Jupyter notebooks for uh, internal information and documentation of the algorithms.
Okay, because I understand that developing models for Airbus is a huge amount of data, so I'm sure it's fascinating how the architecture is. Can you develop about some models used and how you develop, fine tune them, maybe?
Mhm. I cannot go in a further detail, but there the main challenge here was
Mhm.
the time frame that we were talking before. If you anticipate so much the replacement of a piece, you are creating a big damage, and then you are continually updating the aircraft pieces. So
Mhm.
there you are saving money in not having the aircraft on ground, but then you are wasting money in the maintenance. And otherwise, if you don't anticipate enough, you have no value at all because this is what you already have. The plane is a really safe place, and then even you fail, the good thing is that you always have a redundancy. I mean, this is on top of the safety of the plane. This is not to replace the safety. This is just to prevent delays when you are waiting and then they need to change one aircraft for other, or preventing that the aircraft is not in in the maintenance center and then you need to take there and all this is money. But I think that the most important thing is not to lose the horizon in the of the business, uh, because you need to adapt the model you are using to to your use of case. I mean,
Mhm.
in 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 aviation, you cannot use the a neuronal network that you cannot predict what the output is, or you shouldn't because you are in a really controlled space, and then well, you can try to use it, but they are not going to accept it for logic reasons. The safety is the first thing in this world.
Yes.
So you need to focus on this horizon because your tools might be limited for depending on the business you are.
Yes, I understand. So now I would like to ask you about your PhD. So a lot of the time I've heard that when people do research at the beginning and then they tend to go to consulting, I mean, I've heard different point of views, but why did you decide to do a PhD?
Well, the first thing I was offered to do a PhD, and I think this is something that either you do when you are young, or if you are going into important roles in the company, you are not going to go through this because you have another priorities. And also, I like the idea of the PhD because, especially in data analyst, it has been a lot of smoke about people telling about artificial intelligence and so on. And that I think the PhD makes the difference for giving stability to this AI, or give some proof of knowledge, not just that it's what the what the businessman want to hear.
Hmm.
So I think that's the that's why I went for the PhD.
Awesome, thanks. And can you explain a little bit more what is your thesis about?
Mhm. Yeah, we are developing an optimization library combining with surrogate models, which is basically artificial intelligence model uh, replacing the problem, and so that we can boost the optimization. Uh, an optimizer is a tool that allows you to go given a problem the optimum value. If you have the problem definition, the best thing you can do is take the mathematical definition and derive the function and go to the real maximum or minimum value. Um, but sometimes that's not the case. If you are going through complex problem, such as material simulation, building simulation, for example, aircraft simulations, uh, then you have a lot of effects added into a simulator. And, and if you want to have a parameter optimized, you usually can go in the function. Given some parameters, then you have an output. But the things that you want to have a given output, and then you don't know the parameters. So the optimizer can help you to find those parameters by playing with the original value. And here it emerges the field of meta heuristic, that it does not guarantee the optimum, but it can really help. But it has some limitation. Basically, is it explores the space, and then it jumps from one place to other. But this by design implies a sequence of simulation. And imagine you are using a simulator that it takes 1 hour, or it take 5 minutes, 15 minutes in execute. Then the new proposal is not available until you have the result of the previous one, which
Hmm.
this implies that you have a time limitation. And here is where surrogate model applies. A surrogate model is a replacement of the problem by an approximation in machine learning, so that the execution is almost instantaneous, and then you can give the next proposal, instead of in 15 minutes, you can give it in 1 second, and that really boosts the performance. So in our case, the surrogate is acting as a filter, and if the sample is not worthy, then don't waste time simulating it. Just skip it and make a new proposal. And well, our article proves that this really improves, and we make a bigger improvement, which is the pairwise surrogate model. We told before that the surrogate model were acting somehow as a filter.
Hmm.
So in the end, you don't need to define exactly the function. You just need to model the decision of whether you are going to simulate or not. If you are going to simulate something, it doesn't matter that you go to the exact value, because you are going to simulate it and you are going to get the value. And if you are going to skip something, it doesn't matter that you are accurate. You just skip the value, and this is the important point. But for example, you need to focus on where you change from simulating to not simulating. And then you are attacking the problem as a classifier instead of the surface classic problem that you approach to an error surface. And this is the point that I am right now in the thesis. And the next step and the final step will be to find some auto-adaptive parameter to this surrogate, so that you don't need to choose a single technique for creating a twin of the problem. You can just launch all of them, and then the library chooses the best alternative, or the best combination of alternative to that fits the purpose. And the purpose is not, we're not fitting the full problem, but just making those decisions whether to filter or not the proposal that the optimization library, the optimizer has made.
Okay, great. And so I understand that this auto-adaptive surrogate model is really, so once you've used it to find where you need to do the simulations, then it reduces all the possible simulations to a few ones that you will run, but it saves you a lot of time. Is that correct?
Yeah, yeah. Well, it depends on your case. Surrogate is not always the solution. It only applies when you are, let's say, for example, between 5 minutes and an hour or 2 hour simulation.
Mm,
If you are going to 10-hour simulation or a day simulation, then surrogate is not your thing, because
okay.
you still have some sequence by design. So you still need you need the result of the previous simulation to create your model, so
Okay.
you cannot bypass completely that that sequence limitation, uh, but then it saves you a lot of time.
Okay, thanks. And what are the challenges? So I would like to ask you a bit more about the tools, but before I want to know what are the challenges today that you are facing, and how your thesis and the work you're doing in collaboration with Oxford, um, how is it adding value?
Mhm. Well, I think that the main challenge today is to build a product from this library. Once we have the theory and is accepted by scientific community.
Hmm.
Now we need to create a product, and we need to get some finance for um, for developing this product and create some value. And to do so, we are doing some collaborations, some of them with the University of Oxford. We are doing all others with some architecture studios. And let me give you some example of those. We are creating some generative metamaterial design, and in this case, the the mechanical engineering department has a simulation of how a structure works. We connect it with the optimizer so that we want to achieve a behavior of a structure. So this way, the optimizer can design the structure that matches the behavior that you want the structure to have. Another case, well, this can be applied, for example, for weighing optimization or the shunt optimization that I will introduce now. Uh, in the wing optimization, we want to optimize the the shape of a wing of a plane. So we let the optimizer choose the shape that that matches a response that we are defining given some purposes.
Hmm.
And the other collaboration that we are doing with the University of Oxford is a shunt optimization, which is basically redesign a shunt for that it's used in medicine when the child has some liquid in the brain and you want to drain it. It has some risk, it can create some pains, so we want to optimize the way that the fluid is extracted without the shunt being blocked by some part of the brains. um, Again, the optimizer is choosing the best structure that matches this behavior. uh, in a totally different field, we are working with some architecture studios for energy efficiency, so that the optimizer is choosing the materials um, and the sequence of materials in the in the walls,
Hmm.
so that energy it's energy clean, so that it maximizes the time that the building is in comfort zone without using any energy. Uh,
Okay.
the the difficult things about this is that it's a quite abstract value. You
Mm.
can add the optimizer to a wide variety of, of areas, but you always need the expert knowledge to be implemented into the simulators. Otherwise, optimizer by itself is nothing. So it's something that I think it's cross area.
Okay. Okay, great. Thanks. Thanks a lot also for all this application. And I think that this is a problem that we face a lot. It is we're getting to a point where we have very, very great technology, but sometimes there is a barrier in how to apply it for a lot of things, and without the experts, it might be quite hard. And thanks for like sharing, for example, the wing optimization, like defining objects, optimization of materials in walls to be eco-friendly, or also, for example, in the medical field where you talk about the shunt optimization. Great. Can you share maybe a little bit what language and tools do you use developing this library?
Yeah, we are using mainly Python for developing the library. Then in Python we are using scikit-learn to build the different models, and we are using Dask as well to moving from uh, the the developing from developing to production, or maybe not production, to the full simulation, because if the
Hmm.
simulation takes a lot of time, you cannot run it in your local computer.
Hmm.
And we are using as well Slurm. We are uh, working with with the Polytechnic University of Madrid, uh, that they have the CESBIMA, which is a high performance computing center,
Hmm.
and we connect Dask with Slurm so that it enters into the queue and wait all the processes to be run at the same time, and that really makes a difference uh, when doing all these experiments. Otherwise, it would be impossible.
All
And
right.
another thing I'd recommend is the dependency inversion. This, well, this is just uh, something I prefer because it keeps the different modules simple. So you want a
Okay.
module to do something, you don't need to in you make them only to interact with other modules, but you don't have part of the modules spread across the code so that it works.
Okay.
Uh, More or less, those are the tools that we are using right now. Those are simply tools, but I think that dependency inversion it really helps for everything to work in a simple way, and also to distribute the work across the team so that you define specifically the modules and then you interconnect them.
Okay. Great. So I think yes, maybe to close a bit this the thesis part, and then I would like to ask you some maybe personal questions. We're running a bit short in time, but um, but I would like to take the time to answer those few questions with you. What models and metrics do you consider using so far regarding the library you're developing, or maybe more in
Uh,
general, as you prefer?
I,
What kind of
I
models
think
and metrics?
it really depends on the business problem. For
Mm-hmm.
example, we were talking about Airbus. I have some friends working in Sarah.
Mm-hmm.
I've been also doing research.
Mm-hmm.
It depends. For research, you can use neuronal network and you can use all that cutting edge technology. For
Mm-hmm.
example, in Airbus, you need two different features, that it's explicability and predictability. You don't
Mm-hmm.
want a model to be random at some point so that you cannot guarantee the behavior. So it really depends on the case. But it doesn't mean that it does not work. It's just that you can explain the model and that you can rely on the model in a different way. Maybe it's more linear or maybe it's less complex, but it works as long as it adds value. And I think
Okay.
this is the key point here. And I
Mm.
cannot choose a model or a metric. I think it really depends on your use of case.
Yeah, makes sense. So understand your business needs, understand the problem they want to solve, and then find out the best metric. How does a normal day look like for you?
Well, I get up, I go to the office, or if I'm not going to the office, I try to go for a walk and then start working, just to clean your mind and be ready for work.
Mm-hmm.
Otherwise, you will be just from one room to another, turn on the computer, and you will move just 30 meters in total during the day.
Mm.
So I try to walk and clean my mind.
Mm-hmm.
After I start working, I have a meeting with the team. Then I have some meeting with the client. Sometimes not, but most of the time, yes. Uh, and then I I use work for I use time for my PhD, and then I go back home. I do some exercise, some household tasks, but then just relax
Okay.
and be ready for the next day.
So I have three last questions for you. Maybe we can try to answer them 1 or 2 minutes each. So how
Yep.
do you keep learning and be curious as doing research? I understand that you would have a good point of view on that one.
I think you need to find your way. I mean, in my case, I really like solving practical problems, and I see the problems as a challenge, and I think you need to find the way it passionates you. If you don't like it, you are not going to reach a good point, because you are going to get tired. You are going to justify to find any justification to skip that task or to go to another thing. You
Mhm.
need to find the way that you like that problem, or maybe you need to find the problem that you like, but always that you like and you are willing to do that.
Mhm. All right, awesome. Do you have a book maybe to recommend,
Uh, well, I'd say, well, I have my,
or maybe something that you publish? Maybe you're publishing something.
yeah, I
Uh,
have my thesis will be published, and then I have, I will share you the link for the article that we've used. Um, Otherwise, just I think we really learn about the experts of the different problems, and then
mhm.
you need to adapt the AI. So what I'd recommend is to really learn about the areas that you where you are applying the AI. It's not
Okay.
just about the model itself; it's how the model copes with the problem and the data,
Okay.
and then you may be able to create some fusion models of different things, but you understand how this work, and this has a reason. So I'd
Yes.
say that the best thing is to listen to the people who is doing the work now, and in the field that you are working on.
Okay, great. Thanks. And can you share about maybe you would have a message regarding young people that start into artificial intelligence, or a message more in general? Do you want to share something?
I think we need to be passionate about our work, and then we need to focus on a lot of areas, and uh, we need to somehow detach our mind sometimes of those problems, because you need to be expert in lot of things, and then you have the risk of take that personal. For example, I remember when I was working with Airbus on all the Airbus in the planes. uh, that's what is happening, but then you start to overthink, and you don't want to make that personal. This is not going to fail, but you are working with errors. So just try to be realistic and try to have everything in mind. Uh, Not to bias the information, because you need to be focused on some parts,
Hmm.
and your brain is going to be biased. And just try to avoid all the work affect your personal life, and because data analysts, we need to really focus until the very small details if we want our model to succeed. So I think that that goes beyond the work itself.
Awesome. Well, thanks a lot, Pablo, for coming on the podcast. It has been a pleasure having you, and thanks a lot for sharing all those details. I'm really looking forward to see your thesis coming out. So thanks a lot, and have a wonderful day.
Same. Thank you very much for you to inviting me.
Thanks.